Okay. Now, so these are the three Bohr's postulates. Right now, from this, here we are taking the further topics related to the atomic physics, nothing but atoms. Fine. Now, at first, here we need to calculate the radius of the nth orbit. Radius of the nth orbit. How come we consider that this is the nucleus? This is the nucleus. Okay. So, positively centered charge is called nucleus. First orbit, second orbit, third orbit. Like this, number of orbits are present. This is the first orbit, second orbit, and third orbit. Orbit to orbit, the radius can be changed. This is center. From center to first orbit, R1 is the radius. From center to second orbit, R2 is the radius. From center to third orbit, R3 is the radius. From center to nth orbit, we are taking it as Rn. Radius of the nth orbit can be represented as Rn. Rn. Okay. Now, here, listen carefully, ma. Based on this, here we need to calculate the Rn value. Rn value. For that purpose, here I am taking the concept as, listen. In this, for example, any orbit electron is present. For example, here I am taking the electron. This electron is revolving around the nucleus. Okay, if the electron is revolving around the nucleus, then if a body is revolving around another body, one should be considered. What is that? Centripetal force must be equal to centrifugal force. Centripetal force and centrifugal force, these two are the forces which we considered equal. Then that body is revolving in the circular path. That is the condition. And whereas here, if the electron is also revolving around the nucleus, there must be existence of centripetal force and centrifugal force. Then the proper centripetal force, which one is providing here? Which one is providing? So ikkada edaina oka electron revolve avvali anante centripetal force undali. Mari centripetal force undali ante aa centripetal force nu ekkadi nunchi teeskuntunnamu anante the electric force between the two, nothing but center as well as the electron, and thereby here the proper centripetal force can be provided. What is the electrostatic force here? That itself we are calling it as electric force. దాన్ని మనం ఇక్కడ ఎలక్ట్రిక్ ఫోర్స్ అంటున్నాం. ఓకే, సో ఒకటైతే గుర్తుపెట్టుకోండి, ఏంటి అని అంటే సెంట్రిపిటల్ ఫోర్స్ అనేది రావాలి అని అంటే ఎలక్ట్రోస్టాటిక్ ఫోర్స్ ఉండాలి. ఆ ఎలక్ట్రోస్టాటిక్ ఫోర్సే ఇక్కడ సెంట్రిపిటల్ ఫోర్స్ గా కన్వర్ట్ అయిపోతుంది, మారిపోతుంది. ఓకే, సో ఇక్కడ ఈ టాపిక్ లో వాట్ ఈస్ ద electrostatic force? The electrostatic force is nothing but, as you know that in the lesson electric charges and fields అనేటువంటి లెసన్ లో మనకు క్లియర్ గా ఎలక్ట్రిక్ ఫోర్స్ కు సంబంధించి ఫార్ములా ఉంది. ఏంటా ఫార్ములా? దట్ ఈస్ 1/4πε0 q1 q2 by r square. 1/4πε0 q1 q2 by r square. This is the electrostatic force. This electrostatic force between the two. What are the two here? What are the two charges? Oka charge emo ikkada enti ikkada positively centered charge. That is the proton number is Z. Proton number is Z. Z into E. Ze. Okay. So ikkada entidi electron E. Electron ante endamma ikkada E. So idi oka charge. Center lo ee atom nucleus oka charge. ఓకే, సో మరి ఈ రెంటి మధ్య ఉన్నటువంటి ఎలక్ట్రోస్టాటిక్ ఫోర్స్ మనకి క్రియేట్ అవుతుంది. మరి అది ఏంటి? రేడియస్ ఎంత అని అంటే దట్ రేడియస్ ఈస్ నథింగ్ బట్ ఆర్. సో దిస్ ఎలక్ట్రోస్టాటిక్ ఫోర్స్ ఈస్ కన్వర్టెడ్ ఇంటూ సెంట్రిపిటల్ ఫోర్స్. వాట్ ఈస్ ద సెంట్రిపిటల్ ఫోర్స్? దట్ సెంట్రిపిటల్ ఫోర్స్ ఈస్ నథింగ్ బట్, వాట్ ఈస్ ద ఫార్ములా? mv²/r. Okay, now with that 1/4πε0 q1 is nothing but proton number is Z. According to charge quantization, Z into E is the Q1, nothing but related to the nucleus of an atom. And then which one is revolving? Electron is revolving. So according to charge quantization, Q is equal to Ne. Q is equal to, what is the value? Ne. N equal to 1. Only one electron is considered. So 1 into E is nothing but what? E by R. R is nothing but, here I am taking Rn. Rn, radius of nth orbit, Rn square is equal to m. V is nothing but velocity of the electron in the nth orbit. I am taking it as Vn by Rn. In the place of V, Vn. So formula became as mVn square by Rn. This is a simple consideration which we followed. Okay, are you getting ma? No. Okay, once again I'm repeating this, right? Listen carefully. Now, I'm explaining this topic by using another topic related to the gravitation. Gravitation. So how come we consider that? Listen, the earth is revolving around the sun. The earth is revolving around the sun. When the earth is revolving around the sun, how it is revolving? No one is taking the earth around the sun. Earth ను పట్టుకొని ఎవరు వెళ్ళట్లేదు అక్కడ. సన్ చుట్టూ తిప్పట్లేదు అక్కడ. అర్థమవుతుందా? ఓకే, ఎర్త్ ను తీసుకొని పోయి ఒక పర్టిక్యులర్ ఆర్బిట్ లో దాన్ని పట్టుకొని పోయి ఎవ్వరు తిప్పట్లేదు అక్కడ సన్ చుట్టూ. మరి ఎలా తిరుగుతుంది అని అంటే, ద గ్రావిటేషనల్ ఫోర్స్ బిట్వీన్ ద ఎర్త్ అండ్ ద సన్ gives the necessary centripetal force to the earth to revolve around the sun. సన్ కు ఎర్త్ కు మధ్య ఉన్నటువంటి గ్రావిటేషనల్ ఫోర్స్ ఏదైతే ఉందో ఆ గ్రావిటేషనల్ ఫోర్స్ ఎర్త్ కు కావలసినటువంటి సెంట్రిపిటల్ ఫోర్స్ ను ప్రొవైడ్ చేస్తుంది. అలా ప్రొవైడ్ చేయటం వలన ఆ సెంట్రిపిటల్ ఫోర్స్ ను యూజ్ చేసుకొని ఎర్త్ ఏం చేస్తుంది? సన్ చుట్టూ రివాల్వ్ అవుతుంది. The earth is revolving around the sun by using the gravitational force between the earth and the sun. Thereby that gravitational force is converting into centripetal force and rotating around the sun. Is this clear? Is this clear, ma? Fine. The same consideration. Sun is the nucleus. Sun is the nucleus. Earth is the electron. Sun is the nucleus. Earth is the electron. Around the sun, Earth is revolving. Around the nucleus, electron is revolving in the particular orbit. In the particular orbit. So, as same as the consideration of the Earth and Sun, the electron and nucleus. Earth is revolving around the sun. Electron is revolving around the orbit. Their gravitational force. Here, electrostatic force. What is the electrostatic force? 1 by 4 pi epsilon naught Q1 Q2 by R square. There, in the gravitation, gravitational force is converted into centripetal force. Gravitational force is converted into centripetal force. Okay, now here electrostatic force is converted into centripetal force. Both are revolving. Rendu rotate అవుతూ ఉన్నాయి అక్కడ. అక్కడ ఎర్త్ రివాల్వ్ అవుతోంది, ఇక్కడ ఎలక్ట్రాన్ రివాల్వ్ అవుతోంది. Is this clear now? Good. Now come to the further concept. The electrostatic force. Try to remember the concept related to the electric charges and fields. We have electric charges and fields now. Try to remember the topic, electric charges and fields. In the lesson electric charges and fields, we have the Coulomb's inverse square law. According to Coulomb's inverse square law, the electrostatic force between the two charges, this is the Q1 and here this is the Q2. The separation between the Q1 and Q2 is R. The electrostatic force between the two charges is 1 by 4 pi epsilon naught Q1 Q2 by R square. Is this clear?
Yes, sir.
Now, this electrostatic force is converted into centripetal force. What is the magnitude of the centripetal force? mv square by r. What is the magnitude of the centripetal force, ma? mv square by r. So electrostatic force is converted into centripetal force. Is this clear now?
Okay, sir. Okay, sir.
With this, here we are taking further, and that is q1 is nothing but here proton number is z, magnitude is ze, magnitude is ze, so ze. q2 is nothing but only one electron, and this is e. In between these two, what is the distance? Rn, radius of nth orbit. For example, I am taking the last orbit, 1, 2, 3, and so on. That is nth orbit. So that is nothing but Rn, radius of nth orbit. This is nth orbit, 1, 2, 3, 4, and so on. And that's why here radius of nth orbit is in the place of r, I consider Rn. In the place of r, I consider Rn. And what about the v? V is nothing but velocity of the electron. So here in the nth orbit, velocity of electron is considered. Velocity of electron in the nth orbit is Vn. Velocity of electron in the nth orbit is Vn. So 1 by 4 pi epsilon naught Ze into E by Rn square is equal to mvn square by Rn. Is this clear now? Is this clear now, ma?
Okay, sir.
Good. Okay. So here what I am saying is the electric force between the two charges, that is nothing but electric force, is converted into centripetal force. With this, we are calculating the radius of nth orbit right now. Okay. So దీని నుంచి మనము radius of nth orbit ను తీసుకుంటాం. Okay. Now come to the topic. Listen. And in this, it's very clear. And that is Rn get cancelled. I'm taking that Z, Ze into E, Ze square by 4 pi epsilon naught Rn is equal to mvn square. mvn square. Okay, now with this, here we are taking further, and that is now I'm taking the concept as Bohr's second postulate. What is that? Angular momentum of the revolving electron. What's the formula? L is equal to mvr. Here I'm taking that mv, that is vn, r rn, mvn rn is equal to nh by 2 pi. nh by 2 pi. Got it? Now I'm taking the vn separately here. Vn equal to cross multiplication nh by 2 pi m rn. nh by 2 pi m rn. nh by 2 pi m rn. Okay, now with this we are taking further. Listen carefully. Substitute this vn value in this equation. I'm taking this is 1. I'm taking this is 1. Okay, in that equation I am substituting that value. Okay, listen. Z E square by 4 pi epsilon naught Rn is equal to m Vn square. Take the square of this. N square h square by 4 pi square m square Rn square. Everything must be squared. N square h square by 2 square nothing but 4 pi square m square Rn square. Now M, 1M get cancelled, 1 Rn get be cancelled. Now the Rn I'm separating here, Rn. Straight away I'm separating the Rn. Okay, so now this 4 pi, 4 cancelled, pi also cancelled. Okay, I'm separating the Rn value. That's in the denominator. Take the cross multiplication. Rn is equal to, if you take this one as upwards as the cross multiplication, this Z square again comes towards the downwards. So ఇక్కడ ఏముంది ఇక్కడ n square h square, ఇక్కడ ఉండే ఎప్సిలాన్ నాట్ ఇలా క్రాస్ మల్టిప్లికేషన్ చేయండి అమ్మా. ఎప్సిలాన్ నాట్ పైకి వెళ్తుంది, ఎప్సిలాన్ నాట్ బై ఈ Z స్క్వేర్ ని కిందికి తీసుకురండి అమ్మా. Z స్క్వేర్, హియర్ m is present, m Z square. This is the value of Rn. This value here we are representing in some other way. Listen, Rn is equal to, this is also another formula, n square h square by 4 pi square m k Z square. This is another form. This is actual formula which we got from here. This is adjusted formula. What is the adjustment here? K is one adjustment. Observe here epsilon naught is present, here there is no epsilon naught. What happened? K is nothing but what's the value? 1 by 4 pi epsilon naught. K is the constant. K value is 1 by 4 pi epsilon naught. K is nothing but what's the value, ma? 1 by 4 pi epsilon naught. If you substitute the value of K 1 by 4 pi epsilon naught, then you will get this value again, this formula again. Rn is equal to n square h square epsilon naught by m Z square. This is the formula of radius of nth orbit. Got it? Ardhamainda? Okay. Now, from this, I'm taking the one specified formula for this. Okay, one specified formula here we are taking from this equation, and that is listen. Listen, ma. Here h is the Planck's constant, epsilon naught also constant, m is the mass of electron, that is constant, E is the charge of electron, that also constant. If you substitute all the constants there, then you will get the value as Rn is equal to, that value became as 0.53 n square by z Armstrong units. N square by z Armstrong unit. This is the generalized formula for finding the radius of electron in case of nth orbit. If the first orbit in the place of n 1, second orbit R2 in place of n 2, third orbit in place of n 3. This is the generalized formula. How we got this? H is the Planck's constant, substitute there. Epsilon naught, permittivity of the free space, substitute there. And then m, mass of electron, substitute there. And then E, charge of electron, 1.6 into 10 power minus 19 coulomb, substitute there. And if you substitute all the constant in this formula, then what about the remaining one? N square z, that's the numerator, z is in the denominator, n square by z. Okay, if you substitute all these constant, then you will get the new constant. That new constant is 0.53. N square by z. What's the unit? Armstrong unit. 1 Armstrong unit is equal to 10 power minus 10 meters. 1 Armstrong unit is equal to, what's the value, ma? 10 power minus 10 meters. So this is the generalized formula. Okay, now with this, here we are taking for H atom. Nothing but hydrogen atom. For hydrogen atom is nothing but Z is equal to 1, N also equal to 1. Z equal to 1 and N also equal to 1. Z1, N1, then substitute there. N equal to 1, Z equal to 1. 1 by 1, 1 only. Here what about the remaining term? R is equal to 0.53 Armstrong units. This is the radius of the first orbit. So first orbit, no, this I am taking it as R1, radius of the first orbit. Got it? అర్థమైందమ్మా? ఈ ఫార్ములా బాగా గుర్తుపెట్టుకోవాలి. Rn is equal to 0.53 n square by z. For H atom, hydrogen atom, atomic number is 1, and first orbit here I considered n equal to 1. So why? Because radius of the first orbit, so n equal to 1. Then R1 equal to 0.53 Armstrong units. Got it? Okay. Now listen. In the same way, here we calculate the radius of the nth orbit. In the same way, here we need to calculate the velocity of nth orbit. Velocity of the electron in the nth orbit. Velocity of the electron. If the electron is revolving in the nth orbit, what about the velocity of that particular electron? ఏదైనా ఒక ఎలక్ట్రాన్ nth orbit లో రివాల్వ్ అవుతూ ఉంటే ఆ ఎలక్ట్రాన్ యొక్క వెలాసిటీ ఎంత ఉంటుంది అనేది మనం తీసుకోవాలి. Velocity of the revolving electron in nth orbit. Okay, so for that, here we are taking generally, previously we got the formula as V is equal to Vn is equal to, already we got the Rn value, that from the Rn value we can calculate the Vn value. That Vn value is nothing but nh by 2 pi m into Rn. nh by 2 pi m Rn. So if you substitute a radius of nth orbit value here, then that formula became as Vn is equal to C by 137 into Z by n. That formula became like this, meter per second. Vn value is nh by 2 pi m Rn. So ఇక్కడ మళ్ళీ ఏం చేయాలి? Rn వాల్యూ ఇది తీసుకోవాలి, 0.53 n square by z. అలాగే h అంటే ప్లాంక్స్ కాన్స్టెంట్, ఈ 2 pi వాల్యూ ఉంది, వాటన్నిటిని మనం అడ్జస్ట్ చేస్తే అది దేనికి ఈక్వల్ అయింది అంటే C by 137. C అంటే స్పీడ్ ఆఫ్ లైట్ ఇన్ వాక్యూమ్, 3 into 10⁸ మీటర్ పర్ సెకండ్. ఈ వాల్యూకు ఈక్వల్ అయిందట. సో Z by n అనేది అక్కడ వస్తుంది. దిస్ ఇస్ ద ఫార్ములా ఆఫ్ వెలాసిటీ ఆఫ్ ది రివాల్వింగ్ ఎలక్ట్రాన్ ఇన్ nth ఆర్బిట్. దీని నుంచి మనం ఇంకా కండిషన్ తీసుకుంటే Vn is directly proportional to Z by n. Here what is the condition? Rn is directly proportional to n square by z. Rn directly proportional to n square by z. Vn is directly proportional to z by n. అర్థమైందమ్మా? Okay, next. With this, we are taking that angular velocity of revolving electron in the nth orbit. Angular velocity. Angular velocity of revolving electron in nth orbit. Okay, how come we find the angular velocity? As you know the formula. What's the formula? Relation between the linear velocity and angular velocity. V is equal to R omega. In the lesson system of particles and rotational motion. So here we have the relation V is equal to R omega. V is the linear velocity, omega is the angular velocity. So V is equal to R omega. So Vn, velocity of revolving electron in nth orbit, Rn, revolving radius of the nth orbit, omega n, angular velocity of the revolving electron in nth orbit. Angular velocity of the revolving electron in nth orbit. Substitute the Vn value as well as Rn value and Vn value. If you substitute, already we know the formulae. If you substitute those formulae here, we will get the value as omega n is equal to here we have the concept of omega naught into z square by n cube. Omega naught into z square by n cube. What is the omega naught? If you in that some constants we have, if you take all those constants and that constant value is nothing but 4.159 into 10⁻16. 4.159 into 10⁻16. That is the constant of this value omega naught, and anyway z square by n cube. This is nothing but radian per second. What is the unit of angular velocity? Radian per second. Okay. Now, this is the generalized formula. With this, omega n directly proportional to, what is that? Z square by n cube. Z square by n cube. Okay. So now here I am writing Rn directly proportional to n square by z. Already that's on the board. Rn is directly proportional to n square by z. Okay. And Vn is directly proportional to z by n. Omega n is directly proportional to what's the formula? Z square by n cube. Same if you consider omega n is equal to Vn by Rn. Vn, this is the value. Rn, this is the value. If you substitute, then you will get this only, Z square by n cube. But from the formula, how we got that? That's one proof. This is omega n proportional to Z square by n cube. Omega n proportional to Z square by n cube. Got it? Omega n proportional to Z square by n cube. Okay. Now, next come across the, once we know the omega, then with that we are calculating the time period of the revolving electron in nth orbit. Time period of the revolving electron in nth orbit. We need to calculate the time period. Okay. Time period of the revolving electron in nth orbit. What is the general formula of time period? T is equal to 2 pi by omega. T is equal to, what's the formula? 2 pi by omega. Tn is equal to 2 pi by omega n. Tn is equal to 2 pi by omega n. Okay. So now if you take that, Tn is inversely proportional to omega. Already we know the omega n value. What's the value? Z square by n cube. If you write in the place of omega n place to Z square by n cube raste, the denominator lo undi kada, kabatti a fraction emotundi, reverse avutundi. So now that is nothing but Tn proportional to n cube by Z square. So Tn proportional to n cube by Z square. N cube by Z square. Are you clear with this? Are you clear with this? Okay. Now, once we know the time period, we need to calculate the frequency of the revolving electron. Frequency of the revolving electron. Frequency is nothing but reciprocal of time period. So, frequency of the revolving electron in nth orbit. In the same way, 1 by Tn. So, Tn is nothing but n cube by Z square. Then Fn is directly proportional to, in the place of Tn, if you substitute n cube by Z square, the fraction can be reversed. And that is nothing but Z square by n cube. Z square by n cube. So Fn is directly proportional to Z square by n cube. Okay, now I'm writing here Fn is directly proportional to Z square by n cube. So once you know the radius of electron in the nth orbit, with that velocity of the electron in the nth orbit, with that angular velocity of the electron in the nth orbit, with that time period of the revolving electron in the nth orbit, and with that frequency of the electron in the nth orbit. Got it? So all these things you need to remember. Then only it is easy to do the formula problem. Okay. Now, and then if the electron is revolving in the particular orbit, then charge is in motion. Electron nothing but charge. Charge is in motion. When the charge is in motion, with the motionable charge, current can be produced. Electric current అనేది ప్రొడ్యూస్ అవుతుంది. చార్జ్ అనేది రెస్ట్ లో ఉంటే కరెంట్ ప్రొడ్యూస్ కాదు. చార్జ్ అనేది తప్పకుండా మోషన్ లో ఉండాలి. మోషన్ లో ఉన్నప్పుడు మాత్రమే కరెంట్ ప్రొడ్యూస్ అవుతుంది. ఇప్పుడు ఒక ఎలక్ట్రాన్ రివాల్వ్ అవుతూ ఉందనుకోండి, ఆ ఒక ఎలక్ట్రాన్ వల్ల ఎంత కరెంట్ ప్రొడ్యూస్ అయ్యింది అది మనం కనుక్కోవాలి. వాట్ ఈస్ ద జనరల్ ఫార్ములా ఆఫ్ ఎలక్ట్రిక్ కరెంట్? General formula of electric current is equal to I is equal to Q by T. The rate of flow of charge is called current. Rate of flow of charge is current. So I, Q అంటే ఏంటి ఇక్కడ? Charge, magnitude of charge. ఒక ఎలక్ట్రానే కదా, so N into E. According to charge quantization, NE. N అంటే ఏంటి? 1. N is equal to 1. 1 into E, E by, here we need to consider revolving of continuous one loop, nothing but ఒక circular orbit complete చేసేస్తోంది. The time taken to complete one circular orbit, one circular path is nothing but time period. Time taken to complete one revolution, time taken to complete one revolution is known as time period. Okay, so I is equal to ఏమవుతుందమ్మా? E by T. E by T అవుతుంది. ఓకే, సో దీన్ని బేస్ చేసుకొని ఆల్రెడీ మనకు టైం పీరియడ్ తెలుసు, టీ వాల్యూ. టీ ఈస్ నథింగ్ బట్ వాట్స్ ద వాల్యూ? ఎన్ క్యూబ్ బై జెడ్ స్క్వేర్. ఈ టీ ప్లేస్ లో ఎన్ క్యూబ్ బై జెడ్ స్క్వేర్ రాస్తుంది, పైకి వెళ్తే ఏమవుతుంది? ఐఎన్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు ఈ టీఎన్ అనేది ఎన్ క్యూబ్ బై జెడ్ స్క్వేర్ కదా, ఇది ఇక్కడ రాసేస్తే అది ఏమవుతుందమ్మా? జెడ్ స్క్వేర్ బై ఎన్ క్యూబ్ అవుతుంది. జెడ్ స్క్వేర్ బై ఎన్ క్యూబ్. దిస్ ఇస్ ద current produced when the electron is revolving in the nth orbit. Current is produced when the electron is revolving in the nth orbit. Got it? అర్థమైందా? Now, so next we are calculating the magnetic moment. Magnetic moment of the revolving electron. Okay, so that magnetic moment here, I'm taking the concept it as, right away I'm taking m proportional to n. Orbit number of orbit directly proportional to number of orbit. Number of orbit increases, the magnetic moment also increases. So for n is equal to 1, that magnetic moment is called as one Bohr magneton. Bohr magneton, that we are simply call it as Bm, Bohr magneton. One Bohr magneton value is nothing but 9.26 into 10 power minus 24 ampere meter square. That is the unit of the magnetic moment that we will discuss in the lesson magnetism and matter. So Bohr magneton is nothing but, for n is equal to 1, for n is equal to 1, n equal to 1, that's the value. N equal to 1 as well as z also equal to 1. Right? The name of that is nothing but Bohr magneton. Try to remember this. Next, the angular momentum of revolving electron. How come it depends? The angular momentum of revolving electron in nth orbit is also directly proportional to n. So that's nothing but L is equal to, as usually you know that L is equal to Bohr's postulates, nh by 2 pi. H constant, 2 pi constant, then simply we are taking that L proportional to n. With that, L1 by L2 is equal to N1 by N2. This is also another formula for that. So the angular momentum of revolving electron, L proportional to n, then L1 by L2 is equal to N1 by N2. Okay, so like this, radius of electron in nth orbit, velocity of electron in nth orbit, and angular velocity of the electron in nth orbit, time period of the revolving electron in nth orbit, frequency of the revolving electron in nth orbit, magnetic moment of the revolving electron in nth orbit, and then angular momentum of revolving electron in nth orbit. All these things are interlinked. Okay, once we know this, then it is easy to do the numericals related to these type of problems. Okay.